So we're here at the Geological Society of America annual meeting in Indianapolis this year, and I'll be reporting the results of our first year's work from the southern East Humboldt Range, extending along a 20-kilometer long transect from just beneath the detachment fault exposed in the southeastern East Humboldt Range to exposures in the far west, also beneath the detachment fault. And we found some very interesting results. Basically, in the southeastern East Humboldt Range, we got a very different story than we get for the western half of the East Humboldt Range. So let's take that first story first. There we have basically the surface of the Earth at that time, the late Eocene surface, taking Triassic sedimentary rocks, faulting them down against mid-crustal rocks on the detachment fault. We went into the footwall of the detachment fault there and collected a transect of samples for both argon dating of micas and uranium, thorium, helium dating of zircons. And what we found was that both the argon data and the zircon helium data recorded cooling between about 40 million years and 37 million years ago. And so in that 3 to 4 million year period, you must have had these rocks from near the surface of the Earth faulted down against mid-crustal levels. And yet, as you go farther north and across the western flank of the range, you begin to see a very different story, where the ages get progressively younger until by the crest of the East Humboldt Range, you're seeing 22 million year ages, and then from there all the way to the west flank of the range, about 12 kilometers or so farther west-northwest, you see everything coming up in the early Miocene between about 22 and about 20 million years. And so that's based on the argon mica data. Jim will be getting more zircon data from that, but he already has some preliminary zircon results from Secret Creek Gorge, and those also give about 19 million year ages. So the entire western flank of the range was unroofed, had the rocks above the detachment fault pulled the rest of the way off between this 22 and 19 million year period. And so that gives us a two-stage history that took the rocks from deep crustal levels, 22, 25 kilometers deep perhaps, all the way up to the upper crust, less than 5 or 6 kilometers deep, but not all the way to the Earth's surface. And we can say that because we also see some indications of a later Miocene overprinting. And we know that the extensional basin formed in the later Miocene after about 17 million years. But that whole story postdates what we were able to document. And so we see this history, this escalator ride, if you like, from deep crustal levels up to upper mid-crustal levels, 5 or 6 kilometers, between the period 40 million years to about 19 million years ago, but in two distinct pulses with a period of quiescence or when the detachment fault system must have stalled in between.